So dynamic RAM, DRAM. So volatile memory. What is the difference between volatile and non-volatile memory? I had told you. Same example. Example is RAM and ROM. So as the name itself will indicate, volatile memory andrenu. What is the difference between volatile and non-volatile memory? First class only, while starting the memories chapter only I had told.
Volatile is erasable, ma.
Yeah, volatile. So volatile, the contents will not be there. Once you switch off the power supply, the contents will be erased. So that is volatile. So that's why volatile example is RAM. Non-volatile means what? The content will remain. It will not be erased. So non-volatile example is ROM. So data stored in a transistor or one capacitor cell, smaller cell than SRAM, so more per chip but longer access time. See there. Static RAM, actually static RAM will be made up of, if you see the cell of static RAM, 6 transistors. So here what will happen, I had told you in the last class only memory structure. If you have, think now, 4x4 memory is there, like keypad, I was telling. So at the intersection of row and column, what will be there? You can think of as a switch also, this in ROMs, right? So whichever you want to retain the connection, if you want to have one in this cell, so the switches will be connected. If you don't want this cell to be stored as 0, then the switch has to be blown off. Later you cannot connect. So here what is happening in DRAM, at the intersection of row and column, see there, a transistor and a capacitor to store the charge. Capacitor is there. So once you switch off the power, there will be discharge in the capacitor. So every row and column, so it will be, what will be happening? N number of capacitors here. Each cell will have a capacitor like this, right? So whenever you want to read any memory, you are going to put the address of that particular memory cell, and whatever the data is there, through data bus you are going to read out the content of that particular memory. So you need address bus to address the memory location, and data bus to read the memory. So in DRAM, in RAM, what is happening? Only one transistor, one capacitor per cell. So that's why, so more per chip. So you will have more cells you can accommodate in RAM, but longer access time. So to access that memory, the time taken is more. A DRAM represents a stored 1 or a 0 bit in the cell by the presence or absence of the charge on the capacitor. So depending on the contents of the capacitor, charge what is there, depending on that. So what you observe, either 1 or 0 is stored in that particular memory location. So write operation, pull the bit line high or low, activate the word line. So this bit line, whatever will be there, either depending on that 0 or 1, then activate the word line. So activate the word line. On read operation, precharge bit line and intermediate voltage, activate word line, then you sense the charge. So here whether one is contents charge has the charge is there on the capacitor or not, that you are going to sense the charge equalization, rewrite it to restore the charge. So DRAMs, DRAMs are most commonly used as the main memory in computer systems since they satisfy the need for high capacity with relatively low cost. So this is very important. So dynamic RAMs in most of the computers are for bulk memory, right? So DRAMs are most commonly used in the main memory in computer systems since they satisfy the need for capacity will be high and low cost, because in ROMs what you need, one each cell has to be made with a switch there, and once the data, if you blow off the switch, what will happen? That cell will be no use, no longer be usage, right? So yes, static RAM and all, like on chip I had told you, ಏನದು Which memory? On chip, what memory will be there? Cache memory. We were discussing about the cache memory, no? So on chip, whichever like immediately if the microprocessor wants to access a data, think now. If a microprocessor is here, so yesterday I was telling, so microcontroller is there, then he has his own processor, all other peripherals are sitting here, right? RAM, ROM and all those things. Apart from that, cache memory will be there, right? CACH. This cache memory will be basically made up of, each cell will be made up of 6 transistors. That means what? Immediately if any processor wants any data, hardly it will be 8 bytes or very less capacity will be there, so that immediate whatever data is required, the processor will access from it. Otherwise what it has to go? It has to go to the other external memory, address it, get the data byte from there, then process. All those things will be there, or other memory, off chip memory. But on chip only little memory will be there, lesser size, that is called as cache memory. But this will be very costly, right? Costly, and it will be less in size, very less, hardly 8 bytes, 16 bytes, like that, very much less in size. Immediately any data if the processor needs, that will be taken from the cache memory, right? So here, that is the so that are the advantages and disadvantages of DRAM. So each cell is made up of a capacitor. So if the charge is there, then it indicates storage of 1, no charge, then 0. So you can accommodate more number of cells on a memory and the cost is very less, right? So it is used as a bulk memory in computer systems. So that is regarding DRAM. So DRAM refresh. Another property of DRAM cell is that while the transistor is turned off, charge leaks from the capacitor. So this is meaning the term dynamic applied to DRAMs. See there. Another property of DRAM cell is that while the transistor, when you turn off, charge leaks from the capacitor. So this is the meaning of the term dynamic applied to DRAMs. Charge on the capacitor decays over the time. So what will happen? As the time increases, so the charge capacitor also discharges. So typically every cell every 64 milliseconds, so the capacitor will discharge. So you need to refresh each location. So this is very important. So DRAMs organized into banks of rows, refresh whole row at a time. So each row will be refreshed. Can't access while refreshing. So when you are refreshing DRAM, you cannot access. Then synchronous DRAMs, SDRAMs, ability to access a burst of data from successive locations. See there. What I was telling, we had drawn a row and a column. So exactly how we are going to sensitize each column, and we are going to look for each row. So whatever data is there. So like that we were trying to access each cell of DRAM. But here in SDRAMs, what we can do, we can have the bulk, we can read successive locations there. So ability to access a burst of data from the successive locations without having to provide the address for each location address madu badli bulk 1 kilobyte from this data to this data. You get the data antandre from 000 to FFF, then you will get the data. So without having to provide the address for each, so other than the first, and the ability to transfer on both rising and falling edge of the clock cycles also is possible. So double data rate or DDR, this is called as double data rate or DDR, and its successors munde matte ನೀವು computers purchase ಮಾಡೋದ್ನಾಗ ಇದನ್ನ ವರ್ಡ್ ಕೇಳಿರ್ತೀರಾ, DDR, DDR2, DDR3, like that. That means what? Bulk information is accessed in RAMs, not single location wise, right? So to improve the performance. So this is very important with respect to SDRAMs. The next read-only memories, ROMs, for constant data. That means the data is fixed. Like how for washing machine, if you have written the program once, you are not going to erase it or you are not going to change it also. So in such applications, we are going to use the ROMs, right? Ovens have the different programming like that. So for constant data or CPU programs, master ROMs, example he is giving, master ROM, data manufactured into the ROM only. That's what we say. That is for washing machines, ovens, and all, whatever that means what only fixed program will be there. So that much memory locations will be put onto the system. Then next, here you cannot erase it or change it. Nothing can be done in the first case. Second, programmable ROMs. We call them as PROMs. So use PROM programmer. So separately you get the programmer. Like how I think so, you might have not seen the memory programmers, how they will be like. You might have seen in LD labs where you are going to take the ICs for testing, right? So tester socket will be there. You are going to put there and check whether each pin is working or not. So similarly, so programmers, memory programmers will be like that. Just to put the programmer, so there you have to put it, and you can program, like you can send the zeros and the memories from your developing system to target board, like how you are doing it for in VHDL lab. The target board is FPGA or CPLD kit. What you are going to do, once after writing your program, then you will try to remove any logical errors are there, you are going to remove. Then you are going to simulate it, you are going to give the test vectors. So whether the program is working properly or not, input waveforms you will give and check the output waveforms. Once if it is okay, then you are going to send it for programming. So once the hex codes are generating through the JTAG cable, you are putting onto the target board. So there the target board will be what, either CPLD or FPGA. Then again that will be connected to either stepper motor. From the ports it is connected to stepper motor. So you are controlling clockwise or anti-clockwise like that, right? So there the target board was either CPU or FPGA. Here the target board will be the memory programmer, ROM programmer will be there. So you are going to send zeros and ones, whatever you want to be putting onto that memory. So those locations will be stored with whatever data sent. So you can program the ROM. Next, another new type of ROMs are erasable PROMs, EPROM. We call it as EPROM. So how we can, entire cells can be erased. How we can do that? Using the ultraviolet erasable rays. Ultraviolet rays, it will be erased, or electrically erased. That kind of ROMs are called as EEPROM, electrically erasable programmable ROMs, EEPROMs. And one more is flash RAM. So that also comes under ROM only. So this is one of the example for a combinational ROM. So the same 7-segment example we had seen, right? All of you are with me?
Yes, ma'am.
7-segment decoder example we had seen. You remember? So 7-segment. How many types of 7-segment LEDs are there? How many types you can have? 7-segment display. What are the types of 7-segment display? Yes. What are the types of 7-segment display? Sai Kalyan Yadav. Okay. Kadapa. Shivu CK. Akash, make the note. Sai Kalyan and Shivu CK have left the meeting.
Yes, ma'am.
Okay. Kadapa Kadgowdra.
Yes, ma'am.
Sai Kalyan.
Yes, ma'am.
Shivu, Sai Kalyan, you both had left the meeting. ನಡಕ್ ಡಿಸ್ಕನೆಕ್ಟ್ ಮಾಡ್ಕೊಳಂಗಿಲ್ಲ ನೀವಿಬ್ರು.
ಇಲ್ಲ ಮೇಡಮ್ ನೆಟ್ವರ್ಕ್ ಪ್ರಾಬ್ಲಮ್ ಇತ್ತು ಅದಕ್ಕೆ ಕನೆಕ್ಟ್.
ಓಕೆ ಸೈಕಲ್ ಏನ್ ಹೇಳಿ, 2 ಟೈಪ್ ಆಫ್ 7 ಸೆಗ್ಮೆಂಟ್ ಡಿಸ್ಪ್ಲೇ ಯಾವ್ಯಾವು? ನಾನು ಇನ್ನೊಂದು ಕ್ಲೂ ಕೊಟ್ಬಿಟ್ಟೆ, 2 ಟೈಪ್ ಅಂದ್ಬಿಟ್ಟೆ. ಆಗ್ಲೇ 7 ಸೆಗ್ಮೆಂಟ್ ಡಿಸ್ಪ್ಲೇ ನಾವು ಕಾಂಬಿನೇಷನಲ್ ಸರ್ಕ್ಯೂಟ್ಸ್ ನಾಗ ಓದಿವಿ ಅಲ್ಲೇ, ವೆರಿಲಾಗ್ ಕೋಡ್ ಕೂಡ ಬರ್ದಿದೆ. ವಾಟ್ ಆರ್ ದ 2 ಟೈಪ್ಸ್ ಆಫ್ 7 ಸೆಗ್ಮೆಂಟ್ ಡಿಸ್ಪ್ಲೇ?
Ma'am, LED and LCD.
ಸಂಧ್ಯಾ.
Yes, ma'am.
Wait.
Cathode, common anode.
Common cathode, common anode.
Okay, Kirti and Manu, common cathode, common anode. ಸಂಧ್ಯಾನ ನಾವು 7 ಸೆಗ್ಮೆಂಟ್ ಕಲ್ಸತ್ನೆ ಕಲ್ಸಿಲ್ಲ ನಮ್ಮ. ನೀನೇನಂದಿ LED and LCD. See, LED and LCD you told. LED light emitting diode, LCD liquid crystal display. Both are display devices. I did not ask what are the different types of display ಕೇಳಿಲ್ಲ. ನಾನು different types of display ಕೇಳಿದಾಗ ನೀವು LED LCD ಅಲ್ಲದೆ 7 segment display ಅಂತಾನು ಹೇಳಬೇಕಾಗಿತ್ತು ನೀವು. ತಿಳಿತಾ? ಎಸ್ ಸಂಧ್ಯಾ, these are the different types of displays. ಎಲ್ಲದ್ರಗೂ ಕಾನ್ಸೆಪ್ಟ್ ಬೇರೆನೆ. ತಿಳಿತಾ? ಎಲ್ಲ ಸೆಮಿಕಂಡಕ್ಟರ್ ಮಟೀರಿಯಲ್ ಇಂದಾನೆ ಮಾಡಿರೋದು. So this is the symbol for an LED wherein it is going to emit the light there. LCD liquid crystal display concept ಬೇರೆ ಇಲ್ಲಿ. ತಿಳಿತಾ? LCD ನಾಗೆ.
Yes,
And
ma'am.
I asked, my question was what are the different types of 7 segmented display? 2 types of 7 segment display, common anode and common cathode. If you remember, so as there are 7 segments, but many a times we consider dot also. ಇದನ್ನು ಹಿಡಿದ್ರೆ 1 2 3 4 5 6 7 ಇದನ್ನೊಂದು ಹಿಡಿದ್ರೆ 8 ಡಾಟ್ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. ಯಾಕಂತಂದ್ರೆ ಸ್ಪೆಷಲಿ ಕ್ಲಾಕ್ ನಾಗೆಲ್ಲ ಅವರ್ಸ್ ಮಿನಿಟ್ಸ್ ಎಲ್ಲ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಕ್ಕೆ. ಹೌದಾ?
Yes, ma'am.
ಅದಕ್ಕೆ so each segment will have one LEDs. So that's what I had told. I had connected and shown also. So 7 LEDs will be there. 7 LEDs like this. 7 LEDs will be there. If all the cathodes are connected common, and it has to be connected to negative for forward biasing. This is common cathode. So in common anode, what will be there? All the anodes are commonly connected and they will be activated. This we had seen in the last class. Common anode this is. So here this will be connected to each cell. So depending on this, common anode and common cathode will be there. So what kind of if you send 0 in common cathode, this will be lit. In common anode, each cell will be sent 1 1, whichever you want to enable. So to display 1, these 2 are the segments we need to enable. So I am going to send 1 1 in common anode, and in common cathode I will be sending 0 0. This was what my question was. Alright? So liquid crystal display itself is different. So to do all these things, what is the code to be sent to display each number? Again, you need a driver IC is needed for 7 segments. So here the 7 segment will be there, and driver IC if it is there here. So for 7 pins, one will be connected to this, another will be connected to this, another. So like this, idu illi, depending on whatever data you send, 0 or 1, see here 0 1 1 1 ಇದೆ. So 0 all 1 1 1 if you send, what will happen? It will be ellanu unlit madakidu, right? So what will happen? The 0 is displayed there. Only this is sent with 0, right? So like this, from the decoder you are going to send the data to control the 7 segment. Is it clear to you, all of you? This we had studied in the previous class, how each code is generated for displaying 1 henge, 2 en code, 3 en code. So from 0 to 9 we had seen. Do you remember that?
Yes, ma'am.
Is it clear to you, Sandhya?
Yes, ma'am.
If I ask a question, what are the different types of displays, then you can say LEDs, LCDs, then 7 segmented displays and all those things. My question was, what are the different types of 7 segmented displays? It is common anode and common cathode. So each cell will have a single LED there. So depending on common anode or common cathode, we are going to send either 0 or 1 to illuminate those LEDs, so that 7 segment is going to display either 1 or 2 or 3, like that. 3 means like this, 3. So depending on that, the data will be displayed. So a ROM maps, so that's why now we are using, so to store this equivalent codes, we are using a ROM here. A ROM maps the address input to the data output. This is a combinational function, specify using a table. So example, design a 7 segment decoder with blanking input using ROM. So the same thing we had done in the previous class also. Now these codes will be stored in the ROM with the blanking input. One input should be there for blanking, that means for clearing the display. So the decoder has 5 inputs, that is BCD. I want to display from 0 to 9. So that's why I need 4 inputs, right? So with the 3, 2 to the power 3, how much I can display? With 3, how much I can display?
8, ma'am.
With the 3 bits? Huh? Okay, 8 combinations, but right from 0 to 7. Another 2 will remain, 8 and 9. So that's why I need 4 more bits. So BCD to 7 segment display. A decoder has 5 input bits, 4 for BCD code, that is BCD 0, 1, 2 and 3, and 1 more for blanking control. Right? So this is what? A0 to A4 you are going to send the data. Then the output side, D0, D1, D2, D0, D1, D2, D3, D4, D5 and D6. To illuminate A, B, C, D, E, F and G. Dot is not taken. So to illuminate A, B, C, D and E, F, G. So this is address and content. So 0 means this you need to send. 1 is this, 2, 3, like that only, 4, 5, 6, 7, 8 and 9. So 10 to 15, what will happen? This bit is going to high, rest all zeros. 16 to 31 also all zeros. So a 32 cross 7 bit ROM is used as a 7 segment decoder. So here we are going to use ROM as a decoder. So whatever the equivalent values for displaying each BCD number will be stored in a ROM there, right? So the same thing, 7 segment program. So you can see their module, 7 segment decoder. So input register, input is register 1 to 7, right? So total, so you can write it as 1 to 7 there. So total 7 segments. Then next input, what is the array declaration? BCD number 0 to 3. So you can write it as 1 to 4 also, no problem. So 0 to 3 BCD, and input, one more input is there called as blank. So always at sensitivity list, if it is not there, star we are going to, this is very important. So case, blank and BCD. Can anybody explain this statement? Can anybody explain that statement? One mark extra for first internals. If anybody tells what is this going to happen?
Ma'am, if one segment is selected, the blank will be blue.
ಅಲ್ಲ ಸಿಂಪಲ್ ಇದು ವೆರಿಲಾಗ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಏನು ಹೇಳ್ಬಿಡ್ರಿ ಇದು what does this flower bracket indicate? At least now I have given the clue.
Function, ma'am.
Function blank comma BCD is there.
Inputs,
So
ma'am.
you see how many are there?
5.
1 2 3 4 ಅಂತಂದ್ರೆ ಇಲ್ಲಿ ಇದಿಷ್ಟೇ ಏನಿರ್ತಿತ್ತು ಇದು ಇಷ್ಟೇ ನಮ್ದು BCD ಇರೋದು ಹೌದಾ ಹಾ ಮತ್ತೆ ಈ ಕಾಲಮ್ ಏನಿದೆ
Blank.
so what does this indicate? All the clues I have given. When we have used the flower bracket? Verilog constructor.
Concatenation.
Good. Concatenation. ಎಷ್ಟಲ್ಲಿ ಮರೆದು ಬಿಡ್ತಿದ್ರಿ concatenation of blank and BCD input there. 5 bits ಬಂದತಿಲ್ಲಿ. So case blank and BCD here. Did you get all of you?
Yes,
Case
ma'am.
BCD ಅಷ್ಟೇ ಇಲ್ಲ. BCD ವ್ಯಾಲ್ಯೂ ಇದು ಬಂದ ತಕ್ಷಣ ಅಕಸ್ಮಾತ್ 00 ಅಂತ ಬಂದ್ರೆ 00ಕ್ಕೆ ಈ ಡೇಟಾ ಕಳಿಸ್ರಿ ಅಂತ ಅಷ್ಟೇ ಇಲ್ಲ ಇನ್ಕ್ಲೂಡಿಂಗ್ ದ ಬ್ಲಾಂಕ್ ಮತ್ತೆ ಸಪರೇಟ್ ಬ್ಲಾಂಕಿಗೆ ತಗೋ ಬದಲಿ ಬ್ಲಾಂಕ್ ಇನ್ಪುಟ್ ತಗೊಂಡಿರೋದಲ್ಲಿ ರೈಟ್ ಸೊ 5 ಟಿಕ್ ಬಿ ದಟ್ ಈಸ್ ಇಟ್ ಇಸ್ 5 ಬಿಟ್ಸ್ ಓನ್ಲಿ ಇಫ್ BCD ಕಳಿಸ್ಬೇಕಾಗಿತ್ತು ಅಂದ್ರೆ ನಾನು ಏನು ಮಾಡ್ತಿದ್ನಿ 4 ಟಿಕ್ ಬೈನರಿ 00000 ಫಸ್ಟ್ ಟೈಮ್ ನೆಕ್ಸ್ಟ್ 4 ಟಿಕ್ ಬೈನರಿ 00001 ಇವನ್ನೆಲ್ಲ ಬೈ ಹಾರ್ಟ್ ಮಾಡಂಗಿಲ್ಲ ನೀವು whatever this data is there you cannot by heart this right so how do you calculate that from the previous slide what I told so how we have got these values depending on whether the device is common anode or common cathode depending on that so you need to write put the 7 segment here 7 segment here right put the 7 segment I want to store 0 so I need to eliminate this fellow this fellow this fellow this fellow and this fellow so what is there A B C D E F and G so only G has gone 0 whereas rest all have gone high right so active high indication means this 7 segment display is common anode display so high is being sent now next I want to display what next I want to display 1 means only these two 1 means only these two so A B and C so you see there this is A only B and C are lit these all are zeros right so like this the codes are generated depending on common anode or common cathode so in the present case it is common anode we are sending to illuminate 1 means what so it is illuminated if we are sending 0 to illuminate and 1 to deselect that means it will be common cathode so like this the codes are generated for each so this is concatenation of blank and BCD right so depending on if the input is 0 this value is displayed so like that only and finally you come here so finally 1001 now 10 what we had told from 10 to 16 I need to send what 5 bit see what all to be sent 0 10 that is what 10, 11, 12, 13, 14 and 15. So for that value, what should be sent to the segment? Sent only this dash, right? So A, B, C, D, E, F, G. Only high is sent on G. From what value? From 10 to 16. 10 to 16, only this fellow dash is displayed. So that's why what you are observing, 5-bit 100, comma, see there, comma, next where this will be there, comma, this value, comma, this value, comma, this value, then colon. For all these combinations, send what value? 7-bit value 100 to the segment. That is blank for invalid code. For all other default, for all other value, default is what? Send all zeros. All zeros means what? This will be blank only. All zeros you send, so it will be blank. Alright? End case, end module. Is it clear to you all of you? Is it clear?
Yes, ma'am.
Quickly make a note of the, quickly copy the code. Don't copy. First ನೀವೇ ಬರೀರಿ, ಆಗಲೇ ಒಂದ್ಸರ್ತಿ ಬರೆದಿದೆ. This you can take, you write on your own. I will see the books. Don't copy, write on your own. Later we can see. Then you can be true to me how much you are able to write 7 segment. So this problem will come in combinational circuit also, as well in memories also. So ಎರಡು modules ನಾಗ ಬರ್ತದೆ ಅದು problem. many of you are able to do this? Vinay? Shaini, Mehtas Banu, Kirti Nayak, Sandhya, Manu, Akash, Shivani, Kadappa, Bariyak Banta program already.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Combinational programs na ಬರ್ದಿದ್ವಿ ಇದನ್ನ combinational circuits ನಾಗೆ ಈ
Yes,
ಕ್ವಶನ್
ma'am.
ಎರಡರಾಗ ಬರ್ತದೆ ಮೆಮರೀಸ್ ನಾಗ ಬರ್ತದೆ ಕಾಂಬಿನೇಷನಲ್ ನಾಗೂ ಬರ್ತದೆ so were you able to do this correctly output
ma'am.
inputs specify ಮಾಡೋದು inputs BCD output segments ಗೆ ಡೇಟಾ ಕಳಿಸೋದು output so input blank ಇದನ್ನ ಎರೆ ಚೇಂಜ್ ಮಾಡಿದ್ರೆ ನಡೀತದೆ 0 to 6 ಅಂತಾನೂ ಬರಿಬಹುದು 1 to 7 ಬರ್ತದೆ 0 to 3 ಬದಲಿ 1 to 4 ಅಂತಾನೂ ಬರಿಬಹುದು ರೈಟ್ ಇದು ಎರೆ ಡಿಕ್ಲರೇಷನ್ ನಿಮ್ಗೆ ಹೆಂಗ್ ಬೇಕಂಗ್ ಬರಿಬಹುದು ಅದೇನ್ ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ ಸೊ ಆಲ್ವೇಸ್ ಯೂಸ್ ಮಾಡಿ ಕೇಸ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಯೂಸ್ ಮಾಡಿವಿ ಮತ್ ಇದು ಎಲ್ಲರೂ ಕರೆಕ್ಟ್ ಆಗಿ ಬರ್ದಿರಾ ಏನಂತಂದ್ರೆ ಕೇಸಿಗೆ ಎಂಡ್ ಕೇಸು ಎಂಡ್ ಮಾಡ್ಯೂಲ್ ರೈಟ್ ಡಿಫಾಲ್ಟ್ ಏನಿರ್ತದೆ ಡಿಫಾಲ್ಟ್ ಬ್ಲಾಂಕ್ ಎಲ್ಲ ಝೀರೋನೇ ಅದರ್ ದೆನ್ ಆದ್ರೆ 10 to 16 ಬಂದಾಗ only that center this will be this symbol will be displayed so up to here 0 to 9 so along with the BCD blank also is concatenated here using concatenating operator different types of operators odivala so these flower brackets are called as concatenating operator so 5 tick B00 colon then send segment with this value hello heading regarding okay if anything is there I will let you know madam I am in class okay na ಎಲ್ಲರೂ ಕರೆಕ್ಟ್ ಬರ್ದಿರಾ ಇವೆಲ್ಲ ಸೆಮಿಕೋಲನ್ ಇವೆಲ್ಲ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ right segment you are assigning it as 7 tick B0 7 bit binary value right after every statement ಇದು colon ಇದು colon ಇದು semicolon ಇಲ್ಲಿ ನೋಡ್ರಿ ಇವೆಲ್ಲ 10 11 12 13 14 15 ಆದ್ಮೇಲೆ colon for all these 5 combinations you have to put blank only then default is this value end case end module done
Yes,
Yes.
ma'am.
all of you were able to write this code
Yes,
ಎಲ್ಲ
ma'am.
ಕರೆಕ್ಟ್ ಆಗಿ ಹೇಳಬೇಕು ಯಾರ್ಯಾರಿಗೆ ಬರೆಯಕ್ಕೆ ಬಂದಿಲ್ಲ
Yes, ma'am.
ಎಲ್ಲರಿಗೂ ಬರೆಯಕ್ಕೆ ಬಂತಾ anybody tell me if you are unable to write Vinay not answering I'll remove you from the class
Yes, ma'am.
program ಬರೆಯಕ್ಕೆ ಬಂದಿತ್ತೇನಪ್ಪ
Yes, ma'am.
ಕೇಳಿಸ್ಲಿಲ್ಲ okay next in FPGA fabrics SSRAM block can be accessed so in how can you access the RAM so in FPGA fabrics SSRAM block can be accessed as a ROM so how it is always at pause edge of the clock if enable case A then what is this 90H0. D out is what? Hexadecimal lang mention ಮಾಡುತ್ತೆ ಅಷ್ಟೇ ಇಲ್ಲಿ bulk, right? So 90H0 hexadecimal 0 idu, right? D out is 20 hexadecimal value. So like this bulk you can even specify. See that the content of the memory is loaded into the FPGA as part of its programming when the system is turned on. Thereafter, since the data is not updated, it is constant. So 9H1 to 9H1 is what here? 9-bit vector. A 9-bit vector 0 extended from the value hexadecimal 1 to 16. Right? Extended value. Then next 20H0 1 to see here 1 to 6F data is there. 20H0 1 to 6F 20 bit address ಅಂತಂದ್ರೆ ಎಷ್ಟು ಬರಬೇಕಲ್ಲ ನಿಬ್ಬಲ್ ವೈಸ್ 4 20 ಈಚ್ ನಿಬ್ಬಲ್ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ, right? So 20 bit hexadecimal value, only the data is what? 1 to 6F. So 20H016F is a 20 bit vector with the value 01 6F 16. So 16 bit, right? So here ಇಲ್ಲೆಂದು ಸಹಿತ ಇದು 9 bit hexa digit 0 ಇತ್ತಂದ್ರೂ ಸಹಿತ ಉಳ್ಕಿದ್ದೆಲ್ಲ ಏನಾಗ್ತತಿ ಸೈನ್ ಎಕ್ಸ್ಟೆಂಟ್ ಆಗ್ತತಿ. 9 bit vector 0 extended from the value. So ಇಲ್ಲಿ ಏನಂತಂದ್ರೆ 1 ಅಂತ ಅಷ್ಟೇ ಇದ್ರೂ ಕೂಡ ಏನ್ ಉಳ್ಕಿದ್ದು it will be 0 extended. 0 extend ಆಗಿರ್ತದೆ. Like this it is actually 0 1, right? So if you are giving only single bit, the rest of the other 8 bits will be extended with all zeros. So you can write like this also. So when pause edge of the clock will come, only when enable is there, that time this data will be put on to the data bus and indicate. Just an example. Always we have used binary, right? So here H stands for hexadecimal value. For large ROMs, Verilog provides a way of writing the data in a separate file that can be loaded into the ROM during the simulation or synthesis. So use $read memory H or ಅಂತಂದ್ರೆ read memory in hexadecimal or read memory in binary system task. So these are the two tasks, very important. These are the two tasks. Read memory in hexadecimal, but dollar symbol should be there. Then again, read memory in binary with dollar symbol. These are the two system tasks for reading. For ROMs, Verilog provides a way of writing the data in a separate file and that can be loaded into the memory. So to load the data into the ROMs, you can use these two. That is read memory in hex and read memory in binary. Anything you can use, binary or hexadecimal, but it has to be preceded with a dollar symbol. This is very important. So register, one second, register 0 to 19 is there and data ROM 0 to 511. Can anybody tell me what is the memory capacity? Can any tell me, explain me this statement? What is the length and the width of the memory?
512 cross 20, ma'am.
512 cross. Very good. Who is that answering? 512 cross. 512 cross. 512 cross.
20, ma'am.
512 cross 20 bit memory it is. So 512. So the ROM size 0 to 511. So these are the addresses from 0000 to 512. I have written this in decimal. You have to convert that into hexa value. So 512 ROM and the width of the ROM, you see there 0 to 19 is there. So this is 20 bit, this is 20 bit, and this is 512 ROM. So this is how we are going to define the memories in Verilog. So many times we have written this now already. So that's why register 0 to 19, data ROM 0 to 512. So it is 512 cross 20 bit memory. That's what we are going to define. Then next what else is there? Initial $read memory edge, ROM data, ROM always at pause edge of the clock. If enable is there, data ROM, whatever the address you are sending, that content will be sent on to the data bus. The file rom.data specified in the above example, this file rom.data which is specified in the above example could contain the data. Could contain, example ಅಷ್ಟೇ ಇದು 20 bit address ಹಾಕಬೇಕಲ್ರಪ್ಪ ನೀವು. ಸೊ 20 bit ಅಂದ್ರೆ ಎಲ್ಲ zeros, 0126F 01 ಅಂತಂದ್ರೆ 5 nibbles ಇರ್ತಾವೆ 20 bits ಗೆ, ರೈಟ್. 16 bit ಗೆ 6 nibble, 20 bit ಅಂತಂದ್ರೆ 5 nibbles. ಸೊ ಸಮ್ ಒಂದು ರ್ಯಾಂಡಮ್ ಡೇಟಾ ತೋರ್ಸ್ಯಾನಂತ ಲೈಕ್ ದಿಸ್. ಸುಮ್ನೆ ಒಂದು ಅಡ್ರೆಸ್ ಕಳಿಸ್ಬಿಟ್ಟು, ಈಗ ಏನಂತಂದ್ರೆ ಎಕ್ಸಾಂಪಲ್ ನಾನೀಗ ಇದನ್ನ ಅಡ್ರೆಸ್ ತಿಳ್ಕೊಂಡೆ, ಇದನ್ನ ಅಡ್ರೆಸ್ ತಗೊಂಡೆ ಅಂತ ತಿಳ್ಕೊರಿ, 0126F ಇದು ಡೇಟಾ, ಇದು 20 bit ಡೇಟಾ ಇದು. ಸೊ ಅಡ್ರೆಸ್ ಎಷ್ಟಿರಬೇಕು? 512. ಇಲ್ಲಿ ಯಾವುದೋ ಒಂದು ನಾನು 10th ಅಡ್ರೆಸ್ ಅನ್ಕೊಳ್ರಿ, 010. ಈ ಅಡ್ರೆಸ್ಗೆ ಈ ಡೇಟಾ ಹೋಗಿ ತಗೊಂಡ್ಬರೋ ಬದಲಿ ವಾಟ್ ವಿಲ್ ಬಿ ಡನ್, ಆಲ್ ದಿಸ್ ಡೇಟಾ ಅಟ್ ಅ ಟೈಮ್. ಈ ಲೊಕೇಶನ್ 0000 ಐತಿ, ನೆಕ್ಸ್ಟ್ ಲೊಕೇಶನ್ 01, ನೆಕ್ಸ್ಟ್ ಲೊಕೇಶನ್ 017C0 ಡೇಟಾ ಐತಿ. ಸೊ ಲೈಕ್ ದಿಸ್ ಫುಲ್ ಬಲ್ಕ್ ಡೇಟಾನೇ ಬರಿಬಹುದು. ಸೊ ಇಫ್ ಐ ಹ್ಯಾವ್ ಸ್ಟೋರ್ಡ್ ದೋಸ್ hexadecimal values in this file, directly you can give the file name. So using this task $read memory h task, what can be done? All the entire memory locations can be read or written. So this is how you can do it by using these two system tasks, read h, and either in hexadecimal or in binary you can do that, rather than addressing each single memory location. What you can do it in bulk. So the file rom dot specified in the above example could contain the data. So what it could contain for 16 bit, anything. So you can write some other random value, A0, some 4B6, something like that, right? So just the example is being shown. So the only gist of this slide is that there are two system tasks. By using that you can read bulk data from the RAM is the only gist of this file. These two are very important. Then flash RAM. So see there, actually RAMs are volatile. That means what? Once the data is stored, so actually RAMs actual RAMs are volatile. That means what? Each this will have one capacitor connected there. So once the power is switched off, the capacitor will discharge. So there will not, with respect to time. So as the time lapses, what will happen? Slowly it will discharge. So the content will go off, right? That's why we call it as volatile memory RAM. But flash RAM, like what is the concept used in flash RAM? So it is non-volatile memory, readable relatively fast, and writable relatively slow. Writing it will take little bit slow, but reading it will be fast. Storage partitioned into blocks. Again, storage is partitioned into blocks. Erase a whole block at a time, then write or read. So block reading and writing option is there. Once the location is written, can't rewrite until erased. So what is the concept used to see there? NOR flash, NOR gate is being used. NOR flash can write and read the individual locations used for program storage, random access data. Then NAND flash, NAND gate is used. Denser, but can only read and can only write and read the block at a time, used for bulk data, for example in cameras and memory sticks. So whatever pen drives, memory sticks you are using, there the NAND concept is being used. So if you go into the further depth of the memories, what is NOR flash, NAND flash, you can just see the circuits for that, right? So that's regarding the different types of memories. So one small question, different types of memories, or separately explain about DRAM, like that. You will get the additional questions from the main 10 to 12 marks, some 6 marks, 8 marks. This will be an additional question. And the last topic of this chapter is memory errors. Alright, so this is very important. Shall we continue, or tomorrow I'll continue with the memory errors? Okay, crush. You need calculators. Memory errors calculate ಮಾಡಕ್ಕೆ calculators ಏನು ಬೇಕು ಅದನ್ನ ಪಕ್ಕಕ್ಕೆ ಇಟ್ಕೊಂಡಿದ್ದೀನಿ. So that will be the last topic. And compulsorily memory errors 12 marks question will be there.